Okay, so let's have a look at A. We've got z to the 4 equals 1. So using our for the unity thing, remember we've got z to the n equals 1. We're going to end up with the roots will be 1 w, w squared and w cubed, where w is cis 2 pi on n. That's like a rule that we have, but if we didn't know that, well, we would go through the same thing and say 1 is actually cis 0, and we say plus k2 pi, and then to get rid of the 4, we're going to say, well, that just becomes cis k2 pi to the 1/4, which ends up being z equals cis k2 pi over 4, and k can equal 0. When k is 0, that's when we get z is 1. Okay, and then when k is 1, that's when we'll actually just get the w, and so on and so forth. So that's how she goes. So we'll end up with z equals, so 0, that becomes 1. When it's 1, we end up with cis 2 pi on 4, which is pi on 2. And when when k is 2, etc., etc., just times these by 2, right? 2 2s are 4 pi, and so on. That becomes cis pi. And what will that become? That will become 8 minus pi on 2. All right, so now we check on our collator, although we probably don't even need to, because cis pi over 2, that's up here. So that's going to be your I. Pi is going to be minus 1, and minus pi on 2 is there, which is minus I. So that confirms what we had there. Hence show that 1 plus w, well, what shall we do? Change our colour. Go the yellow. Okay, so, oh, well, that didn't change to yellow, did it? Come on, yellow. If we look at this one, w, do it to the side here, w 1 plus w squared plus w cubed, does that equal 0? Well, yes, 1 is 1. What is w? Well, that's our w, this is our w squared, and this is our w cubed, so that would be, w would be I, so plus I, w squared is minus 1, and w cubed is minus I, and that, of course, does indeed equal to a 0. Check the result by vector addition. Okie dokie, let's go with white. So you would use a ruler, obviously. I'm being a bit of a slacker. So we've got 1, we've got I up here. Actually, I wonder if I can do that in different colours. No, we'll stick with the blue. So we've got, and then we've got, so that's 1 on the imaginary. So we've got I, we've got minus 1, and then we've got minus 1 here and 1 there. So if we were to add them all up, if we look at them as vectors, right, add, you would, that becomes, that's your I, and then we add on minus 1, and then we add on, I'll just go down there, minus I, so we get back to 0. So that would be the proof using vector addition. Obviously, you wouldn't put those ones in there, you just draw the square.